Hello everyone, my name is Blaine Pearson and I'm an instructor in Texas Tech's Personal Financial Planning program. In this video, we're going to take a look at the difference between arithmetic and geometric averages. To begin, let's first review what an arithmetic average is. An arithmetic average is simply the mean, so the number of central tendency in a set of numbers. So if we have, for instance, a set of returns such as 5%, 10%, 4%, 9%, and 12%, we can simply take the summation of those numbers and divide it by the amount of numbers in that series. So here we have 5 numbers, so we can take the summation and divide it by 5. And of course, that equals 8. Now when we start talking about returns, and we start talking about finding an average rate of return, the arithmetic average can be misleading, because what the arithmetic average does not take into consideration is the time value of money aspect of those returns. The geometric average is a little bit more complicated, but it's very easy to understand. So here is the equation for it. Don't get too bogged down by this. We'll take a look at how this equation works. So we're going to use the same string of numbers that we had before. 5%, 10%, 4%, 9%, and 12%. So the geometric average, if we plug those numbers into the formula, looks like this. 1 plus 0.05, 1 plus 0.10, etc., and all of those numbers are compounded or times together. We then take the fifth root of those numbers. Algebraically, we can also arrange our geometric average like this. We can take the same compounding effect here, and then instead of taking the fifth root, we can instead take 1 over the set of numbers in the series. So in this case, it would be 1 over 5, or 0.2. Now let's work out the solution. Here is a set of returns taken to the exponential form, so 1 over 5, because there are 5 numbers in that series. If, for example, there were 4 numbers in that series, the exponential form would be 0.25. If there were only 2 numbers, the geometric average would be 0.5. Because there are 5 numbers here, we want to do 1 over 5, and that will be 0.2. We'll reduce it a little bit further, and we'll continue to reduce it into this form. So after we take this compounded together, or times together, we then need to take it to the exponential form, which will give us this. Now, this is not the correct answer in percentage terms. If we want to express this in terms of percentage amount, we need to minus 1 from this and then times it by 100. This will give us 7.96. So when we compare that back to the arithmetic average, you can see there is a difference between the two. This difference, though small, could be much more impactful if, for instance, we had a negative number in our sequence of returns. You'll always note that the arithmetic average will always be greater than or equal to the geometric average. Again, this is Blaine Pearson, and in this video, we covered the differences between the arithmetic and geometric averages.